All right, let's think about part B. So we have dy over dx equals 1 plus e to the x quantity squared and divided by e to the 3x. So I think we're going to follow the same strategy. I want to expand the whole top out and see what I can get at the end. And maybe there's going to be some simplifications coming out of that. So 1 plus e to the x quantity squared is 1 plus 2e to the x plus e to the x quantity squared, which is e to the 2x using the property of exponentials, right? And this is all divided by 3x. Again, this is a differential equation problem, which essentially means that I'm going to integrate this quantity. So I'm sort of like preparing myself for the integration. All right, so you have e to the 3x in the bottom. So maybe we should rewrite this expression as like e to the minus 3x times the whole top, right? I'm writing e to the 3x as 1 over e to the 3x as e to the negative 3x. So that allows me to expand this whole expression and writing that in separate exponential forms, okay? So the first one is e to the minus 3x. The second one is 2 times e to the minus 3x times e to the x. So you have the bases the same, so you're going to add the exponents. So it's going to be e to the minus 3x plus x, which is e to the minus 2x. Now let's do the last one together. E to the minus 3x times e to the 2x. So I'm going to add the exponents again. So I'm going to get e to the minus x. Okay. So as you see, like expanding and simplifying this irrational expression is the way to go. So that allows me to write y as the solution of the differential equation as the antiderivative of e to the minus 3x, e to the 2x, and um, e to the minus x, and all multiplied by dx in parentheses. So what I'm going to do again is to split this integral into 3 parts and maybe do some u substitution eventually. And let's do it. So let me just save some space here. Okay. So here we go. E to the minus 3x dx plus 2 times e to the minus 2x dx, right? And then plus the integral e to the minus x dx. There we go. I have 3 different exponentials and 3 different u substitutions going along with that. So first of all, for the first one, I'm going to use u to be negative 3x, so that du is going to be negative 3 dx. Okay, I'm going to use a different color here. So for this one, I'm going to use u to be negative 2x, and du equals negative 2 dx. Okay, and then let me use a different color here. How about a good green here? Okay, so here we go. I'm going to use one more time. Didn't take it for some reason. Okay, u equals negative x and du equals negative dx. Okay, here we go. So why don't we maybe erase this part completely because we're done with that. Okay, and I'm going to continue from here. Okay, so y is equal to integral. So now du equals negative 3 dx, right, in the first integral. So dx is negative 1/3 du, so I take that out. So e to do u du. Okay. So now in the second integral, I have dx to be negative 1/2 du, and you have also 2 outside that, right? So that should be negative e to do. This time it's blue, u and du. Okay? And in the last integral, du equals negative dx, so dx is negative du. So I have another negative sign. No, I don't have any negative sign. It's plus, so that's going to come with negative e to do u du, right? All right, e to the u du. I think we're all good. Right, e to the u du with different colors here. So yellow, blue, and green. In the first one we have yellow, in the second one we have blue, and in the last one we have green. So all are integrated as e to the u, but for different u's obviously. So minus 1/3 e to the u, which is e to the minus 3x. Let me just use a different color here again. Okay. Minus e to the negative 2x minus e to the negative x. And I'm going to put a generic constant, c, and that would take care of everything. All right, I think we're done, and we found y as the solution of the differential equation provided in the beginning. And we wrote the solution in terms of exponentials. And here, the whole idea was using some algebra, first expanding the top and writing the bottom as the reciprocal that comes with the negative exponent, and then simplifying the whole expression by expanding again. And we use the divide and conquer technique to split the integrals, and we got the final result. All right, this is the end of the video. Thanks for watching. I'll see you in another video. Bye.